Just so everybody knows, I'll be recording a session that's for us, for our file, but it's just gonna be for us. You as part of the POMS network, you have the benefit of participating in this workshop. So welcome everybody. Good morning. I guess it's morning for everybody here, so afternoon, I don't know. So thank you for being here. Thank you for being part of this workshop. Like we have said in the social media, this is the second webinar we're carrying out as POMS LAC, as part of the POMS LAC network. But this is the first workshop that is specifically for people from the POMS LAC community. So this is a benefit that we want to continue providing to all of you. And we hope that you enjoy it. I hope that it's useful. The idea is to generate tools that are useful for you and for your research or your daily work in the industry. So without further, I'm just gonna pass the floor to Christopher Mejia so he can introduce the workshop and Sergio. Thank you all for being here. Thank you, Sergio. Thank you, Chris.
Yeah. Thank you very much, Agatha. Well, hello, everyone. Good morning, good afternoon, or good evening, depending where you are connecting. I think that a big or a vast majority of you are joining us from the morning part of the planet. So welcome. We apologize, by the way, for the delay in connecting with you today. So we were having actually some difficulties to log on into the room and some other stuff, but hopefully we will be able to correct this in the coming webinar that we're going to celebrate. So today it's actually kind of sad for me because it's kind of the last sessions that I'm going to be like co-leading with Agatha, given that I already gave this very interesting position as the president of the Latin American and Caribbean chapter for POMS to my colleague, Dr. Gina Galindo. So I will make sure that in the next session, you will meet her. She's the new president of the chapter, and I will pass this over to her and the new chapter board, okay? But without further, hesitation, so I want to introduce you to my colleague and good friend, Dr. Sergio Caballero from Bolivia. He is actually an expert in many different things, but I had the pleasure to meet him during my PhD studies at Monterrey Tech. But since then, I have attested like his astronomic growth, like in applying many of these artificial intelligence, machine learning, and many other optimization techniques into the field. And when I say into the field, it's not only logistics and operation management and production, but also in the reality. So he has worked for Amazon, he's working now for Walmart, and he has developed plenty of applied projects, and that's why he's here today. To give you this workshop that I'm sure that you will enjoy a lot, because he's also a tremendous lecturer too. And well, with that in mind, Sergio, thank you for your time. Thank you for joining us today. And well, the floor is yours, my friend.
Thank you, Chris. Thank you, Agatha, for having me. It's really a pleasure to be here today to talk about such an interesting topic such as artificial intelligence. Okay, so welcome everybody. Good morning. So the plan for today is the following. In the next hour or so, I'm gonna be first talking about artificial intelligence. So basically, trying to understand what is or what artificial intelligence is and what it has the potential to disrupt so many industries. Then I'm gonna be talking about one specific technology as machine learning, which is under the big umbrella of artificial intelligence. And particularly, I'm going to be addressing what are the different problems that we can solve with such technology. And after that, I'm going to be referring or going to be presenting some applications in the context of production operation management and also supply chain management. So most of the applications that you will see are in the of course, are applied to industry, but they were applied mainly in my study in academia. Unfortunately, I'm not able to share my some industry application, at least not from Amazon and whatnot. Okay, so that's the plan for today. So let's get started. Okay, so the first topic is let's try to give a common understanding of what artificial intelligence is. And we might think that artificial intelligence is still not part of our daily life. So we seem to be that it's a futuristic topic that at some point is going to be in our life, but not today. However, so artificial intelligence seems to be everywhere. So we experience it at home, at work, and also on our phones. Okay. So before we know it, artificial intelligence is going to be part of every product and service that we buy or we consume. Artificial intelligence has expanded into our personal lives in the last several years. So some of the existing applications that are part of our daily base, for instance, are the voice control devices. Every time that we interact with these devices, every time that we request or command for a specific action, that's artificial intelligence in action, right? So every time that the device could play music or read the news or just order some groceries, that's artificial intelligence in behind. Additionally, every time that we use, for instance, Google, and we began typing a search term, and Google will make a recommendation to choose from. So that's also AI in action. So moreover, every time that we, for instance, we identify an item in the real life, so for instance, some sneakers, and we wanted to get more information about the sneakers, for instance, where to buy it and how much will it cost. So we just can take a picture and go to a specific app, and then we can get more information about the item as well. So also, e-commerce retailers such as Amazon are also using extensively AI. So every time, for instance, that we get a new recommendation of products that we might likely buy, it's also AI in action. So Amazon and these online retailers, what they do is they gather information about our preference and also buying habits and also the products that we search. And based on this information, they personalize our shopping experience by suggesting us what are the potential products that we might be likely to buy. A similar experience we see in music and also movie recommendation. So services such as Apple Music or Spotify also track our listening habits. So they know what we listen. So they know the songs that we like. And based on that information, they are able to suggest other songs that we might like to hear. See, for instance, Spotify offers suggestions such as new discoveries, new releases, or all favorites. All of them based on our listen habits. And same thing happens with the mobiles. Another application in our daily lives is also fraud prevention. So every time that we receive, for instance, a message from our financial institution saying about this potential, about a suspicious transaction or activity, that's also artificial intelligence in action. Another application, of course, is navigation. Every time that we use our phone to go from one place to the other. And finally, also chatbots, right? So every time that we interact with these chatbots, they are able to recognize our words and phrases in order to provide us some useful information that we need. Okay, so all of these applications we have played with them, we have experienced with them, so they are part of our daily life. But what is artificial intelligence? Artificial intelligence, or simply AI, so can be defined as the ability of a machine to perform some cognitive functions that we typically associate with human minds. Functions such as perceiving, so what's in the environment, learning, interacting with the environment, and also problem solving. So some of the functions. So the concept of AI is not new. So the concept of AI was developed in the early 50s when Alan Turing developed what is called as a Turing test. So Alan proposed to use this test in order to determine whether a computer, or in this case a machine, can think as humans. But AI is a broad concept. So basically, under this big umbrella of AI, there are several fields and multiple technologies. For instance, machine learning is part also of AI. robotics, expert systems, speech recognition, computer systems, and NLP. So all of concepts that are under this big umbrella known as artificial intelligence. But let's try to give more information about artificial intelligence. So when we listen to the news, so we usually get information that AI has the potential to disrupt so many industries, right? So that it's here not as a temporary thing, but it's here to stay. So the best way to assess if a radical technological change can be radical in the sense that can change my industry is to ask a fundamental question. And that question is, how does this particular technology would reduce cost? So the question that we might be asking is how artificial intelligence might reduce some cost, okay? And to illustrate this point, let me provide an example. And that example is light, electricity, right? So light right now is completely cheap. So it's cheap that we can use all times, right? So we can use in our daily activities. For instance, right now we are using electricity to listen to this webinar. Okay, but also we use a light for so many different activities, right? So we use just for read, for instance. But if we go back maybe a couple of centuries ago, so let's try to be placed in early 1800s. So it would have cost us 400 times what we are paying for our current electricity bills. Okay, so 400 times. So at that price, imagine that we are paying 400 times what we're paying now for electricity. So we would think twice about using light, for instance, to read a book. So maybe we just leverage natural light instead of using artificial light. So what happened next is, so the drop of the price in the electricity light, so basically lit up the world. So basically, virtually nothing we have today would be possible if the cost of artificial light of electricity wouldn't have collapsed to also nothing. So basically, the drop in the price of electricity opened the world, and we can do so many activities. So electricity was disruptive because in the sense that the price dropped, and we can start doing so many activities, right? So artificial intelligence presents a similar opportunity. So this opportunity is to make something that has been expensive to make it abundant and cheap, okay? So similar to electricity, so in this case, artificial intelligence also offers that opportunity to make something, I'm gonna talking about what is this something, to make abundant, okay? That is basically can be shared to anybody and cheap. And the task that artificial intelligence makes abundant and expensive is prediction, okay? So it's not electricity, of course, it's prediction. When we talk about prediction, so we are talking about prediction in the broader term. So meaning that, okay, prediction implies taking information of one kind, so information that we know, and turning information of a different kind, okay? So basically, we can refer to prediction, we can define prediction as a simple A to B mapping, meaning that, okay, so we got information, we got an input, so we have information of one type. So we got information that we know, and we want to convert it information in information that is more useful to us and information that we don't know yet. Okay, so that's the response. So at the end, we care about this V, the response. So that information that is useful for us, but that is an information that we don't know yet. However, we do know the input, so we don't know the A. So basically, this task called as prediction will allow us to get the information that we care, the information that we want to know, based on information that we already know, based on information that we already got. Okay, so this prediction just can be defined as this simple mapping, A to B mapping. Okay, so to get information that we want based on information that is already available to us. And when we talk about prediction, so typically, at least in the context of operation management and supply chain, we also usually think as prediction of something that will happen in the future, right? So we do forecast, or we forecast for thinking in the future, right? So what's gonna be the future demand based on current sales and based on past demand? So usually our thinking about prediction is always the future. However, here we're talking about prediction in the broader term. Of course, we might have an instance that imply the future, but also could be the present. As you will see in the following application, most of them happen in real time. So one of the examples, for example, is this. So for instance, Gmail services, right? So we got an email. So this email is coming from a particular sender. It got a particular subject and it has particular content, right? So we have different characteristics, different attributes that can be described the email, or that can characterize the email. So based on all of these characteristics, based on all of these features, so basically Gmail will flag this email as a spam or not. Okay, so basically it's an email that is desirable for us, or is just spam. So it's taking information that Gmail knows, so the different attributes of the email, and based on that, it's making a prediction of if this email is a spam or not. And this is happening in real time, right? So every time that you got email, it's gonna be flagged as a spam or not. Okay, so it's not taking in the future. We're not assuming that we are predicting something for the future. This prediction is happening in real time. Similarly, every time that, for instance, we have some device that is recognizing an image, okay? So we offer the device or the machine an image, and it's gonna be just recognizing what is the object that is represented in the image, right? So it's providing information that we know, so that will be the pixels, the image, so the different attributes of the image, and based on these attributes, so the machine or the machine or the computer is inferring what is the object that is represented in that image. Okay, so that's also happening at the real time. Another example will be every time that we have an audio clip, right? So we're talking, for instance, to our phone, and at the end, what we got is a transcript, just a text of what we are talking. Again, so we are translating information that we know. In this case, with just our voice, or some words in our voice, and then we are translating that information, converting that information into text. And again, this is happening also in real time. Similar in the other way around, when we got text and we got times and audio. And finally, all translating services. Every time that we put some text, for instance, in English, and we got in French, for instance. Okay, what all these examples have in common is that they are an A to B map, right? So we use information that we know in order to get information that we don't know, but we care. And that's at the heart of artificial intelligence. Okay, so this A to B mapping. But how predictions is related, for instance, to business? How can we use this type of prediction in order to business? So in business, at final, what we care is about taking actions or making decisions. So that's it at the end, at the heart of any business, right? So that this action or making some decisions. However, in order to make a decision, or at least in order to make an informed decisions, so there are different components that we have to take into consideration. So one of them is, of course, we got a prediction, but we got also some inputs, training, and judgment. Okay, so let me put an example in order to illustrate this point. Okay, for instance, let's imagine that we are doctors. Okay, and we have to provide some diagnosis. Okay, so we receive a patient. The patient will tell us about how he's feeling, so the different symptoms, and also we can look at his medical history. So that's the input. So that's the new information that we are getting from the patient or from his medical history. Okay, so we know information. We are getting information about the patient. So we also got some training, of course. We went to medical school. And during 5, 7 or more years, we got some training about the different diseases, about different different treatments. So we got some training. So that's also a part of our knowledge. So we got new information, we got some training, we got but also we got some judgment, right? So judgment in the sense, okay, what are the pros and cons of the different treatments that we can offer to the patient, right? So based on the system, we might diagnose something, we might offer a particular treatment, and we know what are the consequences, positive and negative consequences of that particular treatment. Okay. However, at the heart of all of these elements is predictions. And prediction, basically, in that particular example, would be what is the what's the particular diagnostics that we have for the patient. So basically, what's the illness or what's going on with the patient. So basically, we combine our knowledge, our training, we combine the inputs, the new information that we got in order to predict what is likely going on with the patient. And based on this prediction, so we're assuming that the patient has a particular illness, and based on that, and our judgment will provide some action. So basically, the action is going to be treatment, right? And then we got an outcome. So basically, that's going to be how the patient evolves over time, if it's feeling better or not, and then we can close the loop. Okay. So, and this same information happens in the business, right? Similar to this medical example. So we need to make decisions, but in order to make decisions, we got some training. So we went to a business school or went to engineering school. So we got different information about the situation that we're trying to analyze or make the decision. So we got some also pros and cons, and we need to predict something, right? And the prediction might be just the consequence of the decision that we have to make. And at the end, all of them combine in order to make the action or decision that we are trying to make. Okay. The good thing is with AI, so, or at least in the recent years, so data is more available, right? So we got more data in our phones, we got more data in work. So we are collecting more data. So that means that predictions, so we got more information, so more inputs, right? So it's cheaper to get the data, it's cheaper to analyze the data, it's cheaper to store the data. In this case, prediction will become increasingly possible in more different tasks. As I was saying, right? Since the drop of electricity, or since the price of electricity dropped, the electricity was used for other different devices, right? So not just steam that was back a few centuries ago, but as the drop of electricity, as the price of the electricity dropped, so we started using electricity for different tasks. So similar thing happened with AI. So the cost of predictions will drop, or it's dropping because we have more data, we have more powerful machines. The price of storing a byte is also lower. So prediction is also cheaper in the sense it's cheaper. So we can start using a prediction for other tasks that initially we were not meant to be predicted. We have any questions? Okay, no questions. But feel free to ask any questions at any time. Please.
I don't know. Sorry for interrupting, Sergio. I think that Wai Pingley, she might have a few questions related to the data quality and accuracy. So why? So maybe you can open your mic. We are a small crowd, so maybe you can ask your questions if you want.
Yeah, hi. Yeah, I'm wiping here. Actually, I think I'm not sure whether this is the right time to interrupt discussions. Actually, I'm working in manufacturing. I always had concern with this data accuracy, especially when we are facing complex situations, a judgment on the quality issues, right? I would like the doctors to guide me under this how to overcome these challenges, especially in manufacturing. I'm from quality. I'm a quality person in my factories. I'm making a judgment on the quality of the products.
Gotcha. Yeah, I'm going to be talking about referring about data quality in a couple of minutes. So please bear with me. I'm going to be talking about quality, data quality.
Okay.
Perfect. Thank you.
Okay. So basically, using the data in this way, so to make predictions, or to just get information that we care about from information that we don't know, is not new. So many of the mathematical ideas behind artificial intelligence are actually decades old. But what has changed? What is new? So why now AI seems to be a reality now? So basically, there are three main contributors to that happen. So one of them is, of course, related to algorithmic advances. So basically, we have better ways or better logic or better algorithms in order to read the data, to read the data. As we can see in the last maybe 20, 30 years, we have seen the development of different new algorithms. So for instance, support vector machines that were developed in the early 19th. So recurrent neural networks also in the late 90s as well. So we got better ways of manipulating data, better ways in order to get the outputs from the inputs. So that's one piece. So basically all related to the way that we are computing, or the way that we are manipulating data from inputs to outputs. The second, of course, is related to the availability of data, so explosion of data. And as you know, we are dealing with more and more information, not only in our work, but also in our daily activities. So that's the second component. So more and more data in different formats, of course. And the last one, it's about the increase in computer power and storage. So when I was in high school, I used to use these hard drives, right? So on the hard drive, I believe was maybe one megabyte to store information, right? But now we have these pen drives that is 1 terabyte, right? So we can see maybe in 30 years, we've seen this exponential growth in storage capacity, but not only storage, but also the ability of compute also more information, right? So basically, these three advances about algorithms, about data, and also computer and computer power and storage. So basically made AI a reality. But let me try to provide some specific information about these three components, these three contributions to data. And let me provide some figures to that. So let's first talk about data, right? So we've seen, as I was mentioning, an increasing production of data. So basically, every single day, so 2.5 quintillion bytes of data are generated. So 90% of the world's data has been produced over the last 2 years. So that means that basically every 2 years, so the amount of information, the amount of data that is out there is being doubled. So we're duplicating the information that we do every 2 years. So that's massive. And this data is coming from multiple sources, of course. So every second, there are more than 40,000 searches in Google. So 3 million photos and 700 million comments are posted on a daily basis on Facebook and Instagram, and close to 5,000 tweets every single minute on X. But also supply chains are generating vast amount of information. So for instance, Amazon is selling 480 million items to close to core customers. Every hour, Walmart is dealing with close to a million of transactions. And also UPS delivered more than 20 million packets on a single day. And of course, so we see these large numbers, but for instance, we talk about Walmart, 1 million transactions on every single hour. It's not about information of transactions, but also it's information about the products that Walmart is selling, right? It's also information about the inventory that we got for those items, information about the trucks that deliver those items, information about the location that we got the items stored, information about the vendors, information about the different entities that were involved from getting the product from the vendor to the store. So it's not only this final number, but we can see that there's also a chain of information, vast amount of information that is also being generated. Of course, we have to make good use of all of this information. There are some opportunities in the data. One of them, of course, is the increasingly availability of the data. So more information coming from the phones, but also it's attributed to the lower cost of sensing. So basically, we can also get more information cheaper, and also, as I was mentioning, also the storing information, and in general, better connectivity. Right? So we are better connected in all sense. The information is also coming from traditional structured data, so more information about that is coming from tables, from different transactions, but also in unstructured data format, right? So we can see images, we are generating also audios and different types of additional format as well. And of course, there are some also challenges to deal with this vast amount of information. And the first one is related that data is not really available. Okay, we are collecting data, so that's for sure. So we are, as companies, we are collecting more and more data. But one of the big challenges is that the data is not ready to be used, for instance, in a machine learning model. I'm going to be talking about what machine learning model, but basically it's just raw data, right? So we have to process that data, and that processing, of course, involves a lot of resources and time. Okay, so data is not coming in the shape and in the quality as we would like. So that's the thing. Second thing is about the data quality. Okay, so data might be noisy. For instance, we might have, for the same record, we might have duplicates. We might have just the same record, but just with a couple of different timestamps or a couple of different attributes. It might be sparse. We might have vast information for some transaction, but other information, but we just with lacking information. So that data quality, of course, is an issue. A third factor is related that data is not always consistent across data sources. So we might getting different signals for the same data that we're looking for that are coming from different sources, and that signals might differ to each other. So basically, another effort is to determine what will be the real truth, right? So basically, what's the best source to get our data, and that happens a lot. And finally, processing large data sets it's resource intensive. So in order to use or to make a good use of all of this data that we've generated, we have to process that data. So raw data is, of course, is going to be useless for us. We have to process it. So we have to put that data in a shape and in a quality that can be used for our model. But that process of converting raw data into the inputs that we need for the models, it's very resource intensive. Not only time, but also people. So many times we have to make some manual corrections in the data. So manual means that there's a person that should be making some decision about how to treat the quality. So before automating the process, and that's really a time consuming. Okay, so that's about data. The second component, we talk about the algorithmic side, right? So the algorithmic advances. And let me talk about, if I need to talk about algorithms, of course, I need to talk about machine learning, right? So machine learning basically is the study of all of these algorithms. And the novel thing about machine learning is that machine learning, or ML, represents a fundamentally different approach to creating software, okay? But let me explain first what is the traditional approach of creating software. So basically, every time that we need to code or create software, so basically we're trying to automate some process. So the focus is on codifying existing knowledge. Okay, so we got some knowledge in our heads, and the idea is to translate this knowledge into some lines of code, right? So basically, computers are explicitly programmed to execute a task. So that implies, okay, so I got some inputs. Imagine that I want to make some calculation, right? I just want to sum two numbers. So I would need some inputs. In this case, the two numbers that I want to sum, okay, A and B. I'm gonna be creating the algorithm. So that's the code. Okay, I'm gonna be saying to the program, okay, take the first number, okay, then sum to the second number. Okay, but I'm coding that information, right? So I'm writing some line of codes to tell the computer to perform those tasks. And at the end, okay, the computer will provide some output, which will be just the sum. Okay, but basically what we're doing in the algorithm is we are coding line by line all the actions that I want to perform, all the tasks I want to perform by the computer, right? And of course, when we provide also this traditional approach, we use a lot of these if-else statements, right? So if we meet these conditions, then the code should do these specific actions, right? So the main problem of this approach is that there are so many complex situations in life that will be impossible to code, right? For instance, imagine if you want to code this way and tell a machine to recognize an apple, right? Okay, an apple is round, but we have so many objects that are round. So the apple should be red, but we are also apples that are greens. So in this situation, we must have to write so many if-else statements that will get a very, very long code. Okay, so basically that approach is not practical, right? When we got complex situations, in that situation, so just programming as the old school and traditional approach might not be practical, right? But also there's some weakness in this approach, and that weakness is related to what is known as Polanyi's paradox. So this paradox says we can know more than we can tell. So meaning that we got more knowledge, more information in our head, and that information, that knowledge, usually is very complex to be translated into words and into code. So that way, said we know more. So we know more than we can speak, that we can tell. Okay, so that's the main weakness of this approach. Even though we got the knowledge here, so that knowledge is very difficult to be translated into code. For instance, I got a friend, right, Chris. I see him, and for me it's very simple to recognize him just by looking at his face. But how I should translate this knowledge into a computer? Okay, for me it's no time, right? Immediately I can recognize him. Okay, but how this knowledge that I have of Chris Mejia, or Chris Mejia's face, how this knowledge can be translated into computer? Okay, so that would require, of course, thousands or millions of lines of code. Okay. Okay, I was saying that machine learning offers a new alternative of creating software. Okay, and let's see how this approaches. So basically, how is ML used to address a given task? So the main difference is that machine learning involves coding or programming computers, not from us telling, okay, computer, do these actions or do these particular lines of code or execute this particular line of code. But we are asking the computers to learn from example data or past experience. Okay, so we are providing to the machine examples. Okay, imagine that we want to tell the computer to recognize an image. Imagine a dog. Okay, we are not gonna be providing lines of code with if-else statements in order to execute this task. Okay, we're gonna be providing pictures of dogs in different, of course, in different contexts. For instance, in this case, we got this dog with a cat, and we have a duck as well. I'm going to be providing in different contexts, different animals, different position, dogs in different colors, different breeds, etc., etc. So the machine, okay, will see these examples. Okay, so the machine will see the dog, so the image of the dog, and also a label for that dog. Okay, we're saying the machine, okay, this object is a dog. Okay, so the machine or the computer will learn, okay, this is a dog, another picture with a label as well, dog. So in this way, so providing these examples, the machine will be able to identify what is a dog. So it's a similar behavior when we have a small kid, right? So we got a small kid, for instance, and we want to teach him or her to recognize an object, okay, a dog. So this is a dog, and we point into the dog. We show him the dog. Okay, this is a dog. And then we got another place and we see another dog. Okay, so this is a dog. So by repetition, by providing these examples in different contexts, at the end, our kid will learn what's a dog, right? And same thing happen with the machines in this case. But what we need to provide in this case, it's a mapping, right? So we need to provide to the machine a model. And basically, this task is going to be the following, right? So we somehow will create a model, or the machine will ask the machine to create a model. So this model at the end is going to be taking information, data, and it's going to be providing an output. Yeah, just a typical model. We provide the input, the model will perform some actions and provide some output. So the data, for instance, if we want to recognize a dog, will be just a picture of the dog. Of course, it's going to be a picture that the machine has not seen yet. Okay, we provide a new picture of the dog. Okay, that's the input. So the model will analyze that it got, so the picture of the dog, and the output is going to be, okay, it's a dog or it's not a dog. Okay, so it's basically recognizing if the object that we are presenting to the machine is an object or not. Okay, so that's the task what we want to perform. So basically just recognize an object. Of course, in order to build the model, okay, we need to provide some data. Okay, and at the beginning, of course, it's going to be the picture of the dog, right? So that's the picture that we want to present to the model. But the model doesn't have eyes, so it's not able to recognize the object. So basically the object, so the picture, so that's the domain object. So this somehow should be translated in a language that the machine should be able to analyze. So basically, so these pictures that we have here, pixels, are going to be translated into features. So those features are going to be just vectors of information. So the machine is not able to see a picture, but is able to process numbers, right? Vectors or matrices of numbers. So we are translating this object, right? So the picture into vectors. So those vectors are going to be the input for the model. So the model at the end is going to be it's just going to be reading numbers and providing numbers as an output. Okay, so there's some conversion that we need to do, some processing, some engineering that we have to do. We got the pictures and we translate our pictures into vectors of numbers, right? So features or feature vectors, and those feature vectors are going to be used an input for the model, and the model will tell us if the initial object is a dog or not. Okay. But the question now, okay, I understand this process, but how the model works? How do we identify what's the right model? And of course, for the model, there's some training that we need to do. Okay, so at the end, so this part is just when the machine or when the model is already working, right? So we already got the model, we got the object, we get from the model the features, and we use the features and we make the predictions. We know if the picture is the object in the picture is a dog or not. Okay, but we haven't discussed about how can we get the model, because at the end that's the main task that we should be doing. Of course, we care about the prediction, right? So in the business we care about the prediction. Right. But for us as academia, as a researcher, we care about, okay, how can we develop this model? How can we come up with a model? So that's the task that we have to do. And in order to create, we usually take some training data. So this is what I'm referring to. Okay, so let's provide to the machine different objects of a dog in different contexts, in the sense that we'll get some learning algorithm that will provide the model. Okay, so that's the second task or the second problem that we care. So that's the learning problem. Okay, so the learning problem basically consists of taking training data, some past examples, some old pictures of dogs, and we'll come up with an algorithm. And the algorithm, what basically will provide is going to be providing a model. Okay, I'm going to be talking about what specifically is the model. For now, the model is just the mapping, right? So we provide some data, some inputs, and that provides, and the model provides some output. Okay, but there's some training here, so there's some learning problem also involved. So when we talk about machine learning and when we talk about different algorithms, so basically those algorithms are not applied here in the model, right? So they are applied here in the learning step, in the learning program. So all of the machine learning algorithms are applied here in order to identify what would be the best model. Okay, and the application of the model is just straightforward, right? So most of the task is here. I'm talking about just when we are trying to come up with a model. Okay, all right, talk about it. So one of the huge advantages of machine learning, especially with those advanced techniques or advanced algorithms, is that they are able to produce significantly more accurate predictions than traditional scientific methods. So for instance, so in this image, what I got is a amount of data. So basically, if I go back here, this is the amount of information that I got in my data, right? So that's my training data. So that's what I got here in the horizontal axis, the amount of data that can I use in order to train my model. And in the vertical axis, what we got is performance. Okay. Performance in the sense of how accurate or how good is my model. Okay. For instance, we were trying to recognize dogs. So we got only two options, right? So the output of the model is going to be, is a dog or is not a dog? Okay. And in the training data, what we got is the example of the dog and we got the label, right? So imagine it's a picture of a dog, okay, and the label is, okay, it's a dog. So we know it's a dog. Another picture, imagine that we provide a cat, and say the label is no dog. It's not a dog. Okay, so we know there's a dog. So basically, every time that we make prediction in the training, during the training phase, okay, so what we got is the actual label, so whether it's a dog or not, and we got also the prediction. Okay, imagine we got only two examples, right? First is dog, second is a cat. Okay, so for the first one, we know it's a dog, so that's the actual label, but we make the prediction. The prediction, imagine that this is a dog. Okay, so basically the prediction, so predicting is a dog when actually it's a dog. Okay, so that's perfect. Okay, but in the second example, okay, we got a cat, so the label is a cat, and the prediction says it's a dog. Okay, so we are not predicting well. The prediction should be, it's not a dog, but it's actually saying it's a dog. Okay, so in this case, we can measure the accuracy based on this number, right? In the first case was accurate, 100%, but in the second phase was not. So basically, we had only 2 examples, and in one of them we correctly guessed. So for instance, it's gonna be 50% of accuracy. So this is what we're trying to reflect here in the performance. So how accurate is our predictions, right? When we got traditional methods, so basically the behavior is like this. And traditional, I'm talking about maybe talking about linear regression, maybe about some trees algorithms as well. So basically, what happened when we feed to the model more data, when we got more trained data, so at the beginning, we will see a rapid increase in performance, rapid increase in accuracy. So as we feed the model with more and more data, so the performance gets better and better. Okay, but we reach a point on which, regardless if we provide more and more data, so the performance of the model, the accuracy of the model, so the performance measure of the model is going to be the same, right? So basically, it just reach a point where they don't care about more data. So the performance is going to be exactly the same. Okay. So what happened when we use a different algorithm? So let's try to use a small neural network. So basically, we have a neural network, and we got maybe just hundreds of neurons. You will see that the behavior it's a bit different, in the sense that at the beginning it's very similar, very rapid increase of performance as we feed more data. But then, instead of having like a very constant performance after some point, we can see that there's a likely increase in performance, right? And finally, when we got these very huge neural networks, where we got millions or millions of neurons, we can see that the performance keep increasing and increasing. Of course, there's a cap, right? In the example that we provided, we cannot go beyond the 100% of accuracy, right? There's going to be always a limit. But the main point here is, as we can use these very sophisticated, very large neural networks, the performance is going to be better and better. So that's the good news. However, the bad news, of course, if we want to use this large neural network with millions of neurons, millions of connections, we need to get also millions and millions of records, right, of training data. So that's also one of the issues that we need to identify. Okay, so but we're talking about machine learning. So we basically translate an input into output. But what happens in real life? So basically, it's like a wheel. So I was saying we will get some training data. Training data is going to be coming in different formats. Might be coming from a text, might be coming in from an image, sound, from a machine, or some sensors. But at the end, it's going to be just a combination of them. We got data from different sources, right? So that's our training data. So that's how it's historical data. That's the data that we already know, and for that data, we already got the labels, right? So we already know what's the input, and we already know what's the output. So that's the training data. That's the training data that we'll use in order to come up with the model. Okay. So once we got all the data and the model, so what we're gonna do is, okay, so that's the training phase. That's the learning phase. Okay, so we come up with the model. We got the model, and we wanna use it. Okay, imagine that we got the phone, and we just wanted to recognize our face. Okay, or maybe just you're our phone, you want to recognize a particular object. Okay, so the model is already in the phone. I take a picture of the object, and the model will tell me, okay, what's the name of the object? Okay, simple as that. So we got the model. Now we gotta go to real life, so to real situation, and the situation is gonna be just, okay, let's use the model. In our production, or in our a particular operation that we are managing. So we'll get now real data, continuous data, from the same sources that we got the training data. Okay, but the training data, remember, it's historical information. We already collected. Okay, but at the end, what we want, okay, is apply the model in the real situation. Okay, imagine I have an app that is going to be just recognizing the object. So I got maybe thousands or millions of data in the training, but now, okay, I want to use in the real situation. I want a customer to use our app to recognize an object. Okay, so basically, I'm gonna be collecting in real time the data, so the objects, so the text, image, sound, or the combination of all of them. In real time, I need to aggregate the data and harmonize. So similarly to what I did in the training data set, when I combine from multiple sources, I pass different filters, I improve the quality of the data, I gotta do in step number 3. Of course, this should happen in real time, right? Because we have to make the decision in real time. I don't want to make the decision about, or the predictions about what is the object that we are seeing in text in 10 minutes from now. I want in real time. So all of these aggregations should happen in real time. And then the machine learning, so the model will process the information, already will get the processing information, all the data that is aggregated in order to make a prediction, right? That's what's happening in step number 5. So patterns and trends are relieved and generating insights. In other words, we are using the model with process data in order to come up with the prediction, in order to provide the prediction. Okay, so the app or the system that we're using is going to, okay, this object is a cat, for instance. And at the end, of course, we'll get some good predictions, some bad predictions. Some predictions going to be accurate and other not. And we can use this information in order to provide some feedback to the model. Okay, but basically this is how it will work. Any questions so far?
I don't see any in the chat so far.
Okay, so let's continue. Okay, I since I got only like 25 minutes, I won't spend a lot of time here. But basically here, the main point was also to highlight some opportunities and challenges related to the computing and storage capacity. As I was mentioning in the beginning of my presentation, so now it's cheaper to store information. And this is reflected by this fact that from the period of 1995 to 2005, the cost of storing 1 gigabyte dropped from $300 to less than $9. So it's now it's much cheaper in order to store information. That's all not only reflected in industry, in our work, but also in our personal devices, in our phones. Okay, I will skip this activity for the sake of the time, and let me just try to focus now a bit on machine learning. So right now, what I presented is what is AI, what is has the potential to disrupt some industry that we're talking about, that it offers the possibility of make a particular task known as prediction available and basically non-expensive, very cheap. And as the price of prediction drops, we'll see many of the different tasks that we conceive as problems to be reframed as prediction problems. For instance, autonomous driving, right? Autonomous driving uses a lot of computer vision in order to identify what's the object, and based on that object, what's the action that the autonomous vehicle should be doing. Initially, I mean, that problem of identifying the object was not conceived as a prediction problem, but now it is, because the cost of getting the information, the sensor drop, which makes prediction also cheaper, right? And this trend will continue happening, right? So there's a lot of tasks that initially were not conceived or not thought at as prediction problems that are gonna be reframed as prediction problems. That's the main thing that we discussed when we talk about AI. The second one, I want to talk about machine learning taxonomy, and basically, what are the different problems that we can solve, or classification of different problems that we can deal in the machine learning domain, okay? And basically all the algorithms that we've seen in machine learning can be organized in three buckets, right? So the first bucket is supervised learning. Second one is unsupervised learning, and the third one is reinforced learning. The first one, supervised learning, is basically, I would say, maybe 90% of current AI application will fall within this bucket, supervised learning. And the main attribute of this is what I was talking about. In the mapping, in the prediction, when we try to make the prediction, in the training set, what we got is pairs. So we got, in order to train our model, we already got the A to B mapping. So for the training set, we got the input, but also we got the output. Going back to the example of recognizing an object, what we got is the object, right? The information, the input, but we also have the label that is going to be telling us, okay, this picture or this object is a dog, for instance. So that's the main characteristic of supervised learning. So that means that we got label examples. But label examples, what I mean is that we got the mapping. We got the input, the A, and we got also the B. We got also the output. That's already labeled. In the case of unsupervised learning, so we got what is known as unlabeled examples. So we got the object. Imagine that we got the dog, the object. We have the pictures. What we don't know, we don't have the label. So we don't know if it's actually dog or not. Okay, so that's an unlabeled example. We got the A, but we don't have the B. And finally, reinforcement learning, which is very different to the others. And basically, I'm going to be talking about more about reinforcement learning. But the three buckets, so supervised, unsupervised, and reinforcement learning, and basically encompass all the applications that we see in machine learning. Okay, very briefly, I'm going to describe what is supervised learning. As I was mentioning, so we need some label data. So we need the A to B, or as in this example, we need to provide the X and Y's in order to develop the model. So basically the model, what it's going to be doing is going to be taking the inputs, so the X or the A, and based on the information, it's going to be assigning, it's going to be providing the outcome, which is going to be the Y hat, okay? So the Y is the actual value, the X is the input, so that's the pair, so that's the mapping, X, Y mapping. And the model is going to be taking the X and is going to be providing the Y hat. The Y hat is just the prediction, right? So it's using the X, information about the model or the model itself in order to provide the label. Okay, so that's how this works. The model will get the X, provides the Y hat, and the model is going to be should be built based on some training data, right? So we got some historical data. We use the learning algorithm in order to come up with a model. Once the model is ready, we can use in production, and the model will take some X information, some data, and will provide some labels. So that's very straightforward. Okay, I'm not going to be talking about this particular situation. This is what I already talked about. What is the accuracy of the model? So typically, of course, we want to provide accurate predictions, and usually the training is going to be trying to reduce or increase the accuracy. But usually, when we talk about training the model, so usually the difference between the actual label and the prediction is called cost, right? So basically, we're trying to minimize the discrepancies between actual label and prediction. In other words, what we're trying to do is minimize the cost. And you will see that basically behind all machine learning algorithms, what we're trying to do is just to come up or identify the parameters of the model that will result in the least cost. Okay, so basically we want to find what are the numbers, what are the parameters that we model needs in order to minimize the cost, basically to make the accuracy the best accuracy of our model. The first of the tasks or problems that we can solve is a classification problem. Okay, we're talking about supervised learning. So the first one is classification, and in the case of classification, it's an A to B mapping. We got the A and we got the B's. So we got the A's and we want to provide the B's in real life. A classification algorithm is usually referred as simply as classifier, and it will assign some discrete labels to its inputs. So let me just illustrate this one. So the classifier is our model, right? So we got the model. So this model is gonna be taking some inputs. So those inputs could be continuous or could be discrete. Of course, it's always gonna be numbers, right? So the model classifier only can be fed by numbers. Even though if we got images, we got pictures, we got text, we got audio, all of the information should be converted into numbers, into numbers, and those numbers could be continuous or could be discrete, right? Continuous, we got, for instance, we got maybe we want to estimate travel time. We might got information about the distance. We might got information about if we're traveling, about the type of engine that we got, the type of cars, and the type of wheels, etc., etc. But it's a combination of continuous and discrete inputs. But the output is going to be always discrete. So that's why it's called a classification problem, right? So we're using different attributes of an object or a situation. And based on all of these different attributes, we're trying to classify it as A, B, C, or D. Okay. Imagine if it's want to recognize an object, okay, it's gonna be cat, it's gonna be dog, or what. But always the output is gonna be discrete. Okay. And usually, many of the problems are just implied binary classification. Okay, for instance, in the example I provide of the email, if the email is a spam or not, so that's binary, right? So it's gonna be 0, it's a spam, or 1 is gonna be it's a not spam email. Some of the most common methods under supervised learning, particular classification, are linear classifiers, SVM, so support vector machines. We got also really different methods for nonlinear classifier. When we talk about decision trees and ensemble methods, are also part of this RAM, and also, of course, neural networks. All of these different methods, okay, are used for classification again. So we got a combination of continuous and discrete inputs. We got the model, our classifier, and the classifier will provide an output that's gonna be discrete. Could be multiple labels or different classes, also more than 2 classes, or just could be 2 classes. But at the end, all of these methods, okay, should be trained. If we use a support vector machine, we need to identify what the specific parameters of the SVM, and that identification of the parameters is what is called training. And we use a training data set for that. Similarly, for regression, but in this case, the main difference in regression, of course, is the output. The input, as you can see, is exactly the same, a combination of continuous and discrete inputs, variables or features, but the output is going to be continuous, right? So the output is going to be a number. Some methods that are used, linear regression, of course, and nonlinear regression. Okay, in the case of unsupervised learning, you will see that we don't have the levels. For supervised, we got the A, we got the inputs, the X, and we got also the outputs. So our training set is gonna be those pairs, right? A, B. We got the picture and we got the label. It's a dog. In the case of unsupervised learning, so the problem is very similar in the sense, okay, in supervised, particular in classification, we want to classify, right? So we got all of this data and want to identify, okay, this data, so these examples are dogs, This example are cats, and so on and so forth. We want to classify this data. Okay, in supervised learning is very similar in the sense that we also want to classify this data. We want to identify patterns and structure in the data, but we don't got the labels. We don't know the initial classes. That's the main difference. Okay, as in the example, right? So we have this dot with different colors. We'll use some supervised algorithm in order to classify them, in the sense that, okay, all red dots are going to be grouped together, all the green grouped together, and all the blue dots are going to be also grouped together. Okay, but initially here we don't know if it's a red, or at least no label as red, green, or blue. Okay, and one of the techniques, of course, is clustering. Just again similar to classification, but with the main difference is that we don't get the corresponding labels. Another method is the dimensionality reduction. Especially this happens when we got a large data set with so many features, and some of the features might be correlated to each other. So one good practice is usually to run this dimensionality reduction. So basically, imagine that we got 100 of different features that would characterize our inputs. We got 100 vectors. But as I was saying, some of the vectors might be correlated to each other. So good practice will be, okay, let's reduce the dimensionality, so reduce the number of features that we're using, okay, and try to come out with the most relevant factors, or more relevant features. Okay, and for instance, we can PCA is one way to run this dimensionality reduction, and LDA is also another option. Okay, so two main applications: clusterings, when we want to classify information, but we don't have information about the labels. So clustering is the way to go. Different alternatives came in clustering. And second option is when we got large data set with a lot of correlation in our data set. In that case, we might apply dimensionality reductions. Okay, so talk about supervised learning and supervised learning. Finally, let me present about reinforcement learning. So that's very different to the other two approaches. Okay, and basically what we got is an agent. Imagine that it's a bot with just a person, with just an entity. We got this agent. And this agent is programmed to perform different tasks. Okay, so we got an action. So the agent is going to be performing an action. And this action, of course, is going to be taken in some environment. So there's some conditions or underlying conditions about where the action is going to be performed. Okay, but at the end, so the agent, the entity of the bot will perform the action in an environment. Okay, and based on the action and the environment, it will provide an state. Okay, and based on the state, okay, there might be a change of state or just continuing the same state. It will provide a reward or penalty. Okay, so basically every time that the agent will make an action, it will be rewarded or it's going to be penalized. So basically the agent, based on the actions that he's taking and based on the compensation that he's getting, so reward or penalty, okay, that is going to be informing the future action that are going to be taken. Okay, so the learning here is happening in the action and reward or a penalty that he's getting. Okay, so for instance, if we want to devise route planning, right? Route planning. We want to solve the VRP problem. So for instance, every time that the driver is making an action, okay, I want to go to point A and point B. Okay, but in order to go to point A to B, I got multiple options. I can talk to the left, to the right, with similar distances. Every time that the agent, in this case, the driver, is taking an action, there should be a reward or penalty, right? If you go to the left, so maybe distance is similar, but it will improve the time in a couple of minutes. Okay, in that case, it's going to be penalized. So this type of behavior, it can be incorporated in what is called reinforcement learning. Okay, there's a lot of action, trial and error, and also a lot of reward and compensation. Okay, gonna skip that part. Is there any questions before I briefly discuss about some applications of AI and machine learning?
Yes, there is a couple. Go ahead.
No worries. First, there is Wei Ping. If you want to open your mic, you can ask the question, otherwise I can ask it for you.
Yeah, hello, I'm Wiping. Actually, I have go through this just now the presentation. I actually right now, manufacturing, we have encountered a lot of variability, right? Process variability, different batch of raw material, different source. Sometimes we also introduce new specification environment. So is there any, I want to learn from a real world case, you would recommend us to read later so I can learn from this case so that I can use it in my industry? Because we keep on facing this issue. So how AI can help us on that? Because each time when we feed in new set of data, so I think we will retrain the system again. So if you are facing a system where with high variability, so what shall we do?
Yeah, of course. For the particular question, there are two approaches, right? So the one approach is basically, okay, I got this initial training data set, but that will continually change. So what should I do? Okay, should just as soon as I get more data, should I just incorporate in as my training set and retrain the model? Okay, or alternative, if I just maybe take some corrections to the model, right? So instead of retraining the model, so maybe just adjusting the model, so the parameter for the model is based on the new data, right? So there are the two most common approaches: retrain, so basically from scratch, okay, do all the training. Or the second one is just updating the model based on new information, right? Of course, I mean there are like the two extremes. There are some also options in the middle, of course, and the answer is based on how heavy is the training, right? For you, training is not a big deal in the sense of, okay, you can train the model in just a few seconds, a few minutes. So maybe the first option is the more preferable, because it's not really expensive to retrain the model, right? But you got a model where you have millions of variables, and it will take maybe a few hours or maybe days to train the model. In that situation, for you, it's not possible just to retrain the model every time that you got new data, right? So in that case, you would prefer the second approach, in which you just update the model based on this information and do that based on a certain cadence, right? So you have basically to trade off, or the main trade-off here will be how costly it is to retrain the data from scratch.
Yeah, if the industry we are facing too many variabilities and too frequent changes, I think AI, what do you think AIs can really help? Is it still helpful? Because we keep on retrains our system again, setting up a new model. Each time we change a new source, for example, in terms of raw material, they have to retrain my data again. So do you think it's still helpful?
I would say that first thing is like, I mean, it's like in quality control, right? So in order to make any improvement, so first you will need to stabilize your process, right? So make a process that is at least predictable. Because as I was saying, AI, it's all about prediction, right? So if you got a lot of variability, it's an unstable process when you got a lot of variability. So the predictions are going to be low quality. So the real benefit of AI, of course, is not going to be huge. So I recommend the first thing: let's stabilize the process. Let's make it stable in order to use AI. Okay, because otherwise, again, it's going to be just noise. Remember, so this is as we've seen in statistics, right? This garbage in, garbage out, right? So AI also applies this role. So the quality of the output is gonna be a function of the quality of the inputs. And if you got a lot of variability in our inputs, the outputs are gonna be also not gonna be accurate at all. Oh, okay, I hope this answers your question. So since we are running out of time, so let me just gonna be sharing with the group my presentation. So in the presentation, there are a couple of examples of applications. So the first one is just a classification of what are the common applications that we've seen in the real world, about supervised learning and also RPA. And in the second part of the slide is just a project that we did at MIT Center for Transportation and Logistics, and particular context of Latin America, and that's for the unsupervised learning. Okay, so I'm going to be sharing the presentation with you. So if you got any question, or are you looking for more information about those particular applications of use cases, please shoot me an email.
Thank you. Thank you, Sergio. Thank you for all the information, all the insights you brought us. Actually, there is another question from Sebastian. I don't know if he wants to ask you directly. I think we lost him. Oh, no, there he is. No, maybe I'll just read it. He says, how can we apply AI to production operations management?
Okay, so the first thing of applying is it's about having the right data, right? So usually what happens in our industries is also we start collecting information, we start collecting data, now different aspects. So but even we don't ask the question, we don't pose the question about what this data is going to be used for, right? So the first thing is trying to identify, okay, the task that you're going to be doing. Right, so I want to know this information, quality, right? So I got my product and I want to identify if the quality of the product meets certain characteristics. Okay, so that's what we're trying to do. So I might got the information about the product, and the prediction is going to be the quality. Okay, so quality is meeting the standards or not. Okay. So what information do I need to do in order to come up with the prediction? Okay, do I need a picture of the product just to see how the different attributes, visual attributes? Do I need to take some different measurements of the product as well? So basically, it's okay. Let's identify the task that we're trying to perform. What's the prediction task? Then based on that, okay, let's think about what's the data that you need in order to predict. Okay, what are potential future attributes that you need to collect? So let's design. So let's start first from the task, prediction task, then go to the data, and finally start collecting the data. But I was talking in my presentation that, okay, there's vast amount of data that's being generated on a daily basis. But also the reality of Latin America is that even though we are exposed to more and more data, so we are not collecting the real critical information that we would like to do. All right, and that's the second step I will do. So let's design the task, let's see what we want to predict, and then let's start collecting information that is going to be valuable for that task. I would say that are the two main steps that we should be doing.
Great. Thank you, Sergio. I don't know if there is any further question. Maybe we have time for one more. Okay, Sebastian is following up. He says, what tools based on AI do you use on your daily work?
Sorry, what was the question?
What tools based on AI do you use on your daily work?
I started using a couple months ago ChatGPT. I mean, this is more for reports. That I would say mainly that I'm using, of course, in my phone, right? So a lot of AI, but not a particular application of AI. I would say maybe right now for my work is mostly a ChatGPT. Of course, I use in work, but it's not tools, but it's not an AI tool itself, but a lot of coding in order to come up, identify models and different applications of supply chain management and also production management. But main AI tool I would say is ChatGPT.
Great. Perfect. Well, Thank you, everybody. Thank you for being here. Thank you, Sergio, for the great presentations. So it's very nice to learn from you. And
Thank you
thank
for
you
having
all
me.
for. So just to remind you, thank you for everybody that enrolled into the POMS network. We are trying to generate those initiatives to make a greater network, to have more and more support from the region, and to show how professionals like Sergio are applying and are working on our regions to grow and to improve our I mean, I just got stuck there. But the idea is that please, if you paid for the event, don't forget that we are gonna have more events and in the whole year, and hopefully this initiative is gonna continue for the from now on. So you can become a member from the POM Slack, and that's gonna give you all the access for all these events and all the the network itself, so we can see each other on the events and the conferences, on the global conferences and the local conference. So you're invited here, and thank you for everybody that took your time to be here. So I think for me, that's it. I don't know, Chris, if you want to close.
No, just to thank you all, for being here. As you know, the idea of these webinars is to make sure that you brush up some of the potential techniques that you might heard outside, and actually not only learn about like the methodologies, but how to put them into practice. So that's the main purpose of this webinar. So we are really hoping to have you in the next one that we're gonna have Dr. Natalia Somerville, who is actually a professional who has been developing a lot of interesting work using artificial intelligence for forecasting, inventory, etc. And she has developed plenty of interesting applications. So we hope to see you in around 1 month from now. Okay. Thank you all.
Thank you.
Good luck, guys. Bye-bye.